Hello people, welcome back. Before I got back to my series, I wanted to do a video on C. There's kind of a meme that goes around that C is a terrible language to program in because you have to deal with pointers and manual memory management, and it doesn't have some of the primitives that other languages have, like a string. Like a string primitive. So what I wanted to do is just have a small video that shows that C isn't quite as terrible as you might think it is. So in order to do that kind of demonstration, I'm going to create a dynamic string list. So in Java it might be called a list, in Go it would be called string slice, in C++ it would be a string vector. But that's what we're going to create today as kind of an illustration of a little bit of manual memory management and how would you go about creating your own dynamic array. So let's go ahead and take a look at our directory. As you can see, I just created an empty directory called string list, and it doesn't have any files in there yet. So let's go and create a main.c file, and we're going to let's see, we're going to include a few things. We're going to include standard IO, we're going to include standard library, we're going to include the string library, and I think that'll be good for now. And this is our main function. Let's see, return 0. Alright, so this is kind of a basic function that we have. Also, just as a note, this is more of an illustration and not really a tutorial, so I'm going to assume that you have some programming experience in some language, or maybe multiple languages. That's fine. But this is, and I'm not going to go over all the concepts like pointers and manual memory management and how to do it. It's just an illustration that it's not quite so bad. So what we're going to do is, if we're going to have our string list, what we're going to do is we're going to create a struct. So we're going to have a type def of a struct, and we're going to call it string list. And our string list will have to have a list of strings, and that will be our data. And then we'll have a it has to have a size and a capacity, right? So for all dynamic lists, we need something like that. And that is the definition of our struct. So let's go ahead and create a function that will allow us to create a new one. So we're going to have it's going to return a string list, and we'll say new string list. And what we'll do is we're going to have a string list, and we're going to malloc the size of the string list, and the size will start out as 0, and the capacity, we're actually going to make it 1 to start out with. And that means that what we need to do is we need to have our data we'll have to set up with a single slot for a string. So we'll malloc a size of char star, and then we can return that, and that will be our new string list. So whenever we want to create a new string list, we can call this function. Okay, so what are some of the things that we might want to do with the string list? I'm not going to implement all of them since this is just an illustration, but we'll do a couple of them. So one of the first things that we might want to do with the string list besides creating it is add a string to the list. So let's go ahead and do that. It will be a void string list add, and we'll give it a string list, and we'll add a char star string to it. So the first thing that we want to do is, if we're going to add this string to a list, we need to check if our list is large enough to be able to hold this string. So we're going to take a look at the string list size, and if we add 1 to it, we want to check and see if that is bigger than our capacity. If it is, then what we need to do is we need to take our capacity and double it. And this is a common strategy for a lot of dynamic arrays in many programming languages. Some of them have different factors like 1.5 or something like that, but 2 is actually a very common factor. So the other thing that we'll need to do is we need to resize our data to our capacity size, and we can do that by using the realloc function. So we would give it a pointer to our data, and then we also need to give it a size. So we'll give it a size of char star, and then multiply it by the capacity. And then actually that's good enough for that. So now that we know that we have a capacity large enough, then we can do SL data, and we'll go for the size. That'll be the open slot. We're gonna malloc enough space for our string plus a null terminator, and that's because in C our strings are terminated with the null character, which is a 0. So we're going to make sure that we allocate a string that's big enough to hold our string that we're passing in plus the null terminator. And then what we're going to do is we're going to, let's see, oh yeah, we need to have a copy. So string copy. We're going to copy the SL data, which is SL size, and we can do that. We're going to increment it afterwards. I'll explain that in a second, actually, and we're going to copy that. So what string copy does is it takes whatever is in the second argument and copies it into whatever is in the first argument. And what we're doing here is we're just giving it a pointer to the string slot that we have. And this plus plus is going to make sure that we actually increment our size. So this is actually the same thing as if we did this and then we did SL data or SL size plus plus, right? So we could do this, but it saves us a little bit of typing and space if we just do that. Okay, so now we've copied the string. That's pretty much it. So now we have a string and we can add a string to it. So let's go and test that out, right? So let's create a string list. Oh, it needs to be a pointer, and we'll create a new string list, and then we'll do list. Actually, we'll do string list add, and we'll add, say, hello to our list. We'll add a couple more strings. String list add list hi, and string list add hey. So now we have a few lists or a few strings in our list, and let's go ahead and create. Let's go and look at those strings in our list. So we'll have an int I equals 0, I less than the list size, right? So now we keep track of the list's size. Very convenient for iterating through our list. So let's do a printf. We'll print out our string, which will be list data, and the I will index which string we want to print out. So that's very good. And then let's see if that actually works. So we'll save and quit, and then we'll compile it with our compiler. And then if we run it, we see we have hello, hi, and hey, which are the 3 strings in our list. pretty nice. So already we have a dynamic array of strings, and we can add to it. So what are some of the other things we might want to do? We might want to say find a we might want to find the index of a string, right? So, and if we don't find it, we'll return a -1. Let's do that. So int string list find, and we'll give it a string list. And we'll also give it a string that we're looking for. So what we'll do is if there's a few things. Oh, actually, here we go. So this is the result, or maybe position, and maybe we'll say it's -1 to start out with. And what we're going to do is we'll actually iterate through our list. So string list size. And what we'll do is we'll say if string compare, string comp, if our, let's see, data, so a string equals the string, we know that it's if it's 0, string compare actually returns a 0 if the two strings are identical. So if it's identical, then what we'll do is, actually we can make it a little bit, we'll return the, or actually return the position. That's very good, and we probably won't even need that. So, so if it's ever found in our list, we'll actually end up returning the index of where it is in our list. If we go through the entire loop without seeing our string, then we know that it doesn't exist, and we can return a -1. So there we go. So let's go down here and try, let's do a printf find in list. And what we'll do is printf position of, let's see, let's look for the position of high, right? And we'll do string list find. Let's see, we've got a list, and we're going to find high inside there, right? And then let's look for something that doesn't exist in there. So position of greetings. And then, oh, you know what? Let's put a couple new lines in there. And then this will be, we'll be printing out a position. There we go. Print out a position and then a new line, and we'll do string list, whoops, find list greetings. There we go. So let's try this out. Let's do a compile. And we can see that we're going to find stuff in our list. The position of high is actually equal to 1. The position of greetings is -1, which means it's not found. If we go back to our list, we can say that this is the 0th position, and this is 1, and this is 2, so we found high in the first position. So we actually created a string list find pretty easily. Maybe another thing we might want to do is delete a string in the list. So let's implement that too. So let's do void string list remove, and we'll give it a string list SL, and we're going to give it an index. And then what we'll do is if the index, one of the things that we're going to assume here is that the index is actually proper. So we're not going to do any checking if the index is negative or the index is beyond our list. We're going to assume that somebody validated their input before they call this function. And there's a whole philosophy behind that, which I'm not going to go into a rant on, but we're just going to move ahead. So let's go, let's see. So what do we got to do? We've got to, okay, so let's go and let's take SL. We're going to do the data at the index. And what we're going to do is, since we're doing manual memory management, we'll free the memory for the string at that index. And then what we'll do is, just to show to ourselves and everyone else that there is nothing there, that the pointer is shouldn't be pointing to anything, we'll set the pointer to null. Okay, so then what do we do after we have freed up that memory? So we've deleted the item from the list. The next thing that we want to do is move all the items up, right? So if we delete something from the middle of the list, then we'll just move each item forward one. So let's go ahead and do that. So we'll say for int I equals, let's see, index, and I less than the SL of size. Actually, what we'll want to do here is, what we'll want to do here is less than size minus 1, I believe. We'll have to do some testing and check on that. So what we'll do is for SL size minus 1, what we're going to do is we're going to say, okay, we're going to take SL data index, and we're gonna say it will be equal to SL. Whoops. Insert SL. Okay, so it will equal to index plus 1, right? So that will allow us to move an item forward, right? So we're taking the item ahead of our index and we're moving it into where the index is. So then what that will do is that will allow us to get to the last item. So then the last item in our array we should free up, or we should set to null, right? Because now it doesn't contain anything. So let's go ahead and do that. So SL will do SL size, and then we're going to actually we need to make our size less, right, eventually, and we'll set it to null. So I think we're going to have to test this out because I don't know, we just wrote it. It's good to test it. So let's add a couple more. Let's add a couple more string lists. Let's add a couple more strings here. Let's add goodbye. Okay. Now what we can do is let's go down to the bottom here, and we'll remove something from our list. So let's do a string list remove. And we're going to remove, let's try to remove high, right? So that has index of 1. So let's go ahead and do list, and we're going to remove the thing at index 1. And then what we'll do is we'll print all of our list again. And in fact, what we'll do here is let's create a little function where we print a thing. So instead of having to write that loop all the time, let's have a string list print. And we're going to give it a string list pointer to a list. And then what we'll do is we'll put that in there. And I think that'll work. That'll be pretty good. So that will allow us to print our string list. List.size. Okay, that should be good. So let's take this, we'll delete it, and we'll call string list print list. Okay, so that'll be good. So now we remove something here. We'll do string list print okay. So let's try this. Let's see if we've got. Oh, you know what? Let's also put a kind of a little title in here that says remove. hi from list. Okay, so let's see if we can do that. We'll compile. Oh, I made a little bit of a mistake, I guess. Cannot convert from void star to string list. So them main C 39 and 41. So let's go to 39. What do we got here? So string list remove. ls data index equals ls sl data index, right? So that should be good. And then SL, what is going on over here? So SL data, SL size minus. Okay, so that should be that. Let's see, there's another thing I did not identify. So 41 has to point to a structure union. So let's do that. Okay, so SL, not S, SL, right? Lots of typos. Okay, so then I have another thing, reference and function, main, unresolved externals. I'm just having lots of typos right now, I guess. So let's go and print. So there's something, maybe something stringless print. Let's see. There's an error somewhere. Oh, I see it. This needs to be a print F. Okay, so cl main. All right, main.exe. Okay, here we go. So remove hi from the list. So we've got hello, hey, and then actually we have a slight problem, right? Because we've got hey twice, and really what we should have is we should have hello, hey, and then we should have, I think, greetings or something like that at the very end. So we do have a bug, so let's try to debug it. So, and that's what I was talking about with the string list remove, right? So it goes to the end of, goes to the last item at the line, right? And so it should, let's see, let's do a print F, and we'll say moving item, let's create this up. So that way we can see SL data index +1. So that way we can see exactly what we're moving up. So let's go and do that, cl main and main.exe, and then we're saying, okay, we're gonna move item hey up, and then it says, okay, we're moving item hey up. That doesn't really make sense, actually. So why do we get hey twice? So let's go and, okay, so size, so, okay, so what we do here is we free the string, we set it to null, and then what we're going to do is we say, okay, we're going to set the index. Oh, I see what I did here. So this should not be index. This should be I, right? Right, so we'll have I instead of index, and this over here will be I. So cl main, main.exe, aha, hello, hey, and goodbye, right? So that makes much more sense. So if I just didn't make any typos, it would be fine. So now we've successfully had add and remove and find. Let's see, I could probably go on a little bit longer, but I don't want this video to be too long. But hopefully, actually, let's do one more thing. Let's do some organization. So one of the things I like to do is put everything in a single file, and that way you can play around with it and get it working. Once you've got some stuff working and your file starts getting bigger, so this file is like 69 lines long. It's not that long, But once it gets bigger and you've proved that you've got it working, what you can do is you can start to separate things out a little bit. So let's copy our main.c into string list.h. So, oh, that's right, copy main.c. I'm used to Linux to string list.h. Okay, so now we've copied, and you can see we have two copies of our main.c, which is now main.c and stringlist.h. So what we're going to do is we're going to open up stringlist.h, and we're going to delete all the stuff that we want that's going to be in our main.c file. So we don't need any of these include files. We just need our string list things. So let's go here. We don't need the main function, right? So we'll delete that, and we'll keep our string list print here too. That's kind of nice. So then we're going to open up main, and we'll delete all of our string list stuff, right? So let's go through here, and we're going to delete string list print. Okay, delete. And now what we can do is we can actually include our string list.h file, and now we have a nice clean main file, right? And we can just write the stuff that we want in our main, and then our string list file has just our string list stuff in it now. We should be able to compile if we didn't make any mistakes, and it still runs our same program. And that's it. So hopefully you can see, like, dealing with this, once you have that library written, it's not so bad, right? So you've got the, first of all, writing it wasn't that bad in the first place. And then once you have it, you can treat it kind of like a vector, right? So I'm just adding to a string list. Really, this would be kind of the equivalent, like in C++, where you would have, say, lists dot, what is it, push, and then you would push high on there or something like that, right? So that's kind of what you would have in C++. In Java, you might have like a list.add or something like that. So this has that same kind of idea, but instead of having kind of this object where you're giving it messages, you just have a function that you call, and you give it your list and the thing that you want to add. So not too bad. So that's about all I wanted to talk about today. Thank you for watching. Till next time.